Welcome everyone to this talk, Automate Serverless and Event-Driven Approach to DevOps. This talk was born around 1 year ago when me and my team was working on some problems we had in our AWS environments. Now I've been giving this talk several times before. This is like probably the 8th or 10th time I'm doing this talk, and over time things evolve. And last thing I figured out is that I think a better title for this talk is actually a serverless and event-driven approach to Slack ops. And yeah, as I said, talk evolves. And before getting on stage today, I was sitting in the speaker's lounge and just preparing my slides and preparing my computer. And yeah, and asked one of my friends, should I really be doing modification to my slide 30 minutes before I get on stage? And his response was, no. Luckily, I do not listen to my friends, so you get a brand new version that's 30 minutes old. Today, I'm going to talk to you about what started 1 year ago. We were looking at our AWS accounts and figured out we had a few problems that we needed to solve. We had a few problems in our environments that needed our attention. My team that I was working on, we are responsible for the platform in our AWS environment. So we take care of our AWS accounts, we take care of the security of the accounts, and we take care of some of the common services that we are running in those accounts. And there are 3 things I'm going to go over today that was the start of everything, and I'm going to take you on that journey from the problems and onwards to the solution and where we are today. So, but who am I? My name is Jimmy. I work as a principal cloud architect at Sambla Group. I'm the founder of serverlesshandbook.com, a place where you can find a lot of my different serverless adventures and solutions I've been building. I'm an AWS serverless hero and a AWS user group leader. So if you check out the AWS sponsor booth outside, you will figure out and see our AWS community and where you can find us. When I don't do things like that, and talk to you about serverless and event-driven architectures, I do a lot of grilling and barbecuing, and I actually do have a few talks on those topics as well. So I need to give you some background into everything before we get started into our technical solution. So I need to tell you about the customer or the company that this is built for. It's built for My Money, which is part of Sambla Group where I work today. My Money is a fintech company based here in Malmö. We are a loan broker, and we are focusing on car financing. And as a loan broker, we basically sit between you as a customer and the banks that handles the financing. Our normal business hours is between 8 a.m. in the morning and 8 p.m. in the evening. So that's basically when car dealerships are open and are using our systems to do operations and selling cars. We are a very small platform team that took care of everything in AWS. So we're basically 3 people doing this. The first thing that drove these changes are around cost. It's always around cost. Cost is always the primary reason for change. And as I said, we are operating between 8 a.m. and 8 p.m. The first thing we notice is that we are having 3 environments up and running all the time. We have a development environment, test, and production. And our developers, we are all based here in Malmö, and we're working like 8 to 5 normal business hours. So we were thinking, do we really need to run our development environment outside of those business hours? Are it really necessary for that environment to be running in the middle of the night? The second thought was, since we are having business 8 till 8, and there's basically no traffic to our production environment during midnight and onwards and middle of the night, because car dealerships are not open, of course, do we really need to run everything fully available? Meaning that during daytime, we run 2 copies of everything. So if one service fails, there's always a second copy of that service that can take traffic. But during night, is that really necessary? Because if that service fails, our container solution will spin up a new service, but it just take a few seconds or a half a minute for that to happen. And in the middle of the night, that may be not that important. So we took two decisions we wanted to do. We wanted to do environment shutdown outside of office hours of the development and test environments. And we wanted to scale down our production environments during midnight or during the nighttime. The second thought, or second thing we had, was around security. When you work in the fintech industry, IP allow listing is still a big thing. So we have allow listed our IP addresses with our partners. They allow list their IP addresses with us. And we have also placed our development and test environments behind IP allow listing. So those environments are not reachable outside of the office. So we're blocking everything that's not coming from the office IP. Now, people need to work from home. And what we did then was people went into the environment and added their home IP through the allow list. Well, fine, that worked. There's only one problem with that, and that's we as the developers, we are lazy. So we do not remove our IP addresses. We forget and we are lazy, and which led to that we had an IP allow list with around 100 IP addresses. And basically we knew 3 of them, which was our office IP addresses. So we took the decision what we needed to have was a way for us to reset these IP addresses or reset these allow lists. And we also wanted to have notifications around security findings. We do have a lot of personal information, and what we wanted to do is we have Macy to scan for personal information, and we have encryption with KMS. If we find personal information that is not encrypted, we want to know about that. So we wanted to have a notification system around that. The third part is around operations. We needed a way to perform operations and do monitoring of our environments in an easy, simple way. And we definitely wanted a single pane of glass where we could see everything from operations and monitoring. And we wanted to have some form of audit trail, what is going on from an operations point of view in our environment. So we went ahead and implemented all of these things. And we were pretty happy because, environments were shutting down, we were saving money, and everything was looking back good. And we presented everything to the teams. And the first thing the team said was, but what if we need to solve critical problems during the weekend? Well, of course, that could happen. Car dealerships are open during the weekend. There could be a problem. You have to fix it. So our solution was, you navigate here to AWS. Here's a console. You start this step function. Here's the test event you're going to add. And you just click here, and everything just spins up. Well, that didn't fly. It was like, one more place to go. I don't want to do that. Can you make it easier? So we had to take one step back and figure out what are we trying to do and what are we trying to accomplish. And what we wanted to do and accomplish was we wanted to reduce cost. We wanted to increase the security. We needed an easy way to do operations. We wanted to have this single pane of glass from operations and monitoring perspective. And we wanted an audit trail. These are the things we wanted to create. And we needed to make this as easy as possible for our developers to use. So that's when we figured out that Slack is our common ground. That's what we use for all communication, and that is where developers are chatting all day. We're doing huddles and we're doing channel chats and DMs. So Slack is the common tool where everyone is already hanging out. So the idea was, let's bring as many tooling as we possibly can into Slack. And let us automate as much as possible of our processes using Slack. And by this then remove the obstacles and make it very easy for everyone to use. So we started building our own Slack integration. Now, AWS already has AWS Slack bot. We had a look at that, but it couldn't really do what we wanted it to do. And it could do so much more things that we didn't really need. So in the end, we decided that it's better we just build something simple on our own. So we introduced My Money Bot, which is a bidirectional communication between a set of different services in AWS. where we get notifications. We can do different operations toward our environments. And we can also communicate with our IDP provider, Auth0, and make calls to that operation saying that, okay, I want to imitate this service. I need a service to service or machine to machine token, and we can communicate that directly to Auth0, get that in Slack, and you can use that in your local environments and your local testing. So we went ahead and built all of that, and the benefits and outcomes from this work that we reduced cost with almost 60% by shutting down and scaling down environments during out of business hours. We improved the security. Now we have an easy way to handle and these allow lists of IP addresses. And we definitely reduced context switching for everyone. So there's a single place where you can do all of these operations. Now, let's look at some architecture and do some technical deep dive into this solution and how it's been building. Throughout this deep dive, I'm going to use primary two things as my examples. It's a starting and stopping of environments and allow listing and resetting IP addresses. I will also show a short example of the monitoring solution. There's way more things that we can do besides these three, but if I would give you a deep dive on every single one of those topics, this talk will last to midnight. So I decided let's focus on the two things here that was actually the driving force of the entire implementation. So we had three things that was important for us when we started this implementation journey. It needed to be serverless and it needed to be event-driven. And the reason for being serverless and event-driven was that this will not be used frequently. It'll be used a few times per day. And having that running like a long-running container where we pay per hour, that wouldn't be beneficial for us. So serverless was the key thing. It must be serverless. The second part was that it must be modular building blocks. So we can add and remove things easily. Because if it's a hard thing to extend this, that will never happen. And things will just rot and die. And the third thing, we need multi-account support because we are running our different environments isolated in different AWS accounts. That's perfect use of AWS accounts as isolation holders. So prod is running in one account, dev in one, and test in one. So we needed to have support for multi-account setup. So if you're looking at an overview, 10,000 feet overview of the account integration, this is basically what it looks like. We introduced a new service account, and that is where Slack do all of the communication. So Slack communicates into an Amazon API gateway in the service account, and then uses Amazon Event Bridge to filter out these events to different accounts, development, staging, and production. If you add a few more details, Slack communicates, as I said, API gateway. Then we have a Lambda function that does a lot of authorization. It does a lot of different command parsing. It does a different form of filtering. And then we have different event buses. We have separated the buses in different domains. So we have one event bus for commands and one event bus for system messages and monitoring. And the reason for this is we do not want business logic to leak between them. So we wanted to create separate domains so we can separate all of the logic. And then in the environments accounts, things are implemented in a different way. They receive their events and act on those things. So we had a few design decisions when we started building this. The first one, as I already touched on, is using the multiple event buses for domain separation. That was important for us, so we could easily separate business logic. We also took the decisions to not use any form of direct integrations. So even if the event bus running in the service account would be able to invoke a Lambda function or a step function in one of the environments account, that was the decision not to do that. We wanted to keep that logic separate because if the service account has these tight integrations to the actual part that will do the operations, removing or changing that implementation will be harder. And also, there could be a possibility we want to implement things in a different way depending on if it's production, or if it's development, or so on. And the third thing was we never ever use the default event bus that comes with AWS accounts. That bus is left alone. That's always left for the AWS services to communicate with us. We do not use that for our business logic. That's one of the best practices when building event-driven architectures in AWS and using Amazon Event Bridge. Leave the default bus alone. Build and create your own custom buses for your applications. So these were the 3 design decisions we took early on, and those stick till this day, and it's still implemented. If we're going to look at the operations part of everything and how that's been implemented, very simple. It looks like this. We have a Lambda function. That is our primary player in all of this. And if you want to add something, we add support for the command or in that Lambda function, and then we need to implement the operations in each account. This function has a lot of different responsibilities. One thing is making sure that the command is valid, parsing the commands, and the second one is to do advanced filtering. For example, if a user writes /mm, which is the name of our bot in Slack, /mm, stop environment production. That's probably not something we want to do. And allow. So that filtering is handled here in this Lambda function. So if someone would try to stop the production environment, nothing will happen because that will never reach the production account. So how do we use and configure our different commands? We use a simple YAML file that consists of a top command, in this case environment. That is our top command. Under that, we have subcommands like start and stop for the environment. So /mm environment, start or stop. And then we have arguments. And here we have allowed values. So for this command, the arguments that we allow is development staging. If someone sends something else, that will not happen. We will not take care of that. It's an invalid command. So that's where the filtering happens. So in this command file, we can easily now add and remove commands, and that Lambda function will just have the support for it. So looking at the code for this function, one of the first things it does is create a Slack parser. And the Slack parser is our own home-built version of a Python argument parser. So that is what loads up the command file and parses all the commands and making sure that everything is valid. The second thing that's happening is that we register our command /mm. And what we're using here is we're using Slack Bolt. And we're using the Lambda implementation of that API coming from Slack and the SDK coming from Slack. So we register our /mm bot, and we register an acknowledgement saying processing command and an hourglass. And we register our process command, which will be a lazy command. Because Slack has this thing is if you write the bot, you need to respond back within a certain time. If you don't do that, Slack considers the command as a failure. So that's why we acknowledge directly that we took the command from them, and then we do a lazy process and actually do the actual implementation, because some of these commands takes very long time to run. So we're looking at the processing of a command. We start by processing the command, making sure it's still valid. And then we do a publish. And this is where we're sending the event onto the Amazon Event Bridge and making sure we can translate it over to the different AWS accounts. So we create the metadata. One of the things we do, we can set user ID, username, channel ID, and other things. And then we call our publisher. And it sets the source as My Money Operations. We set the domain as a command, which we can then use for filtering in our different buses. And we build up the actual Amazon Event Bridge event that will be sent over to our event buses. One thing that we are using here is we're using the metadata data pattern or the envelope pattern. This pattern was introduced a few years ago, and it's been become one of the common standards in the industry when it comes to event-driven architectures. So we have a metadata block and a data block. It basically works like this. We have an envelope wrapper. So in the metadata block, we add versions, things like the event version. We add things like the username, the channel ID, and all of those things. That will be wrapped into the metadata. And then in the data block, that's where the actual command are located and the data for that command. And by doing this, we can do advanced filtering. We can keep track of different versions of different event types. So the second part of an operation is, of course, to implement it in the different environments accounts. And all the commands flows into our Amazon Event Bridge. We also have the possibility to do scheduling. Here we can show we are doing a allow deny that's been implemented by a simple Lambda function, and then start and stopping environments more advanced and built on step functions. What's really important in this design and this implementation is that each of these operations or parts in the command chain is operated or implemented as its own nano service. So it's super small and it's implemented by Lambda functions, step functions. And this gives us a super easy and flexible way to extend everything. So if we want to extend with a new operation, we could build one of these new nano services and hook that onto the correct event that will be flowing over from our service account. So let's deep dive on the allow and reset IP implementation and how that's been set up. It basically looks like this in a high-level picture. We get the command to allow and deny things. That is run a command, implements a Lambda function that does allow listing towards our different web application firewalls. And then we have a reset part that does this every night. And looking at this, the allow and deny part has been implemented to run on demand only. So allowing and denying IP addresses is only run on demand, meaning that someone actually writes in Slack that they want to allow their IP address. They can actually also write that they want to deny their IP address if they want to try something like a filtering and IP filtering functionality. But that's only run on demand, and that's implementing in a Lambda function. The second part is the resetting, and that's running on a schedule, and that runs every night, and that has been implemented using step functions. The reason we are using different implementation technologies here, like a simple Lambda function for allowing, but step function for resetting, is that even if allow would fail, it's not that big of a deal, because the user can still run the command one more time. They will be a bit annoyed that it didn't work first time, but they will run it one more time and their IP address will be allowed. But when we are resetting everything, we need that to fully function. We don't want any failures in the resetting part, and we want to have some form of error handling. And that's super easy to implement using step functions. So we use the built-in error handling and retry mechanism that comes with AWS step functions. Reason we have different implementation technologies for these different things. So let's run a demo. Demos are fun, and I'm going to apologize already now when I change to the new slide because it will be super bright. Sorry. So let's run a demo for allow listing on my IP address. So we can see that I'm trying to refresh here. I get a different ID in CloudFront. Doesn't work. I move over to my Slack operations and I start typing out /mm IP, which is a primary account, and as a subcommand allow. As a parameter, I add my IP address and which environment I want to allow. I get quickly response with the one you saw from the implementation that we had a processing command and the hourglass. And when we're completed, I got a notification back saying it's been done. So let's go back and refresh. It takes a few seconds for this to take effect. And there we go. I get everything up and running. So this command runs very, very quickly. It doesn't take that many seconds. It was actually recorded in real time. Now, the starting and stopping is a bit more complex and way more implementation parts. And from a 10,000 feet, it looks like this. We will get the command to start or stop an environment into our event bridge. This is moved over to a second step function directly. And that step function takes care of some filtering and take care of some adding some parameters and stuff like that. And then what is happening is step function take care of some filtering, adding some parameters, and what happens is it posts an event onto the event, one more event bridge. Now the entire process kicks off and we can start running this. The first thing we do in the start scenario is to make sure we start our databases. Because without the database running, our containers will start to fail, so we must start the database and ensure that that's up and running before we move on. The second part, starting up our ECS containers and everything is spinning up, communicating with the database. And the last part is to start a client VPN, so you can actually VPN into the accounts and you jump into the boxes in AWS. So each part here has been implemented as a step function based, one more time, nano service. So each part in this operation is a step function and is responsible for a small, tiny part of the entire start and stop flow. And this has been built using a classic saga pattern. So when the database has been starting up, what it does, it posts an event back to the event bridge saying that, hey, I've been started, or I failed to start. Then the next part in the saga pattern can pick up on that event and then starting the ECS services or just aborting the entire saga pattern if something has been failing and send a notification back to us in Slack. So looking at the database startup, this is built on the step functions. So we start by getting the input and then we loop all of our different clusters. So here we use the built-in map state that comes from AWS step functions. So we collect a list of all our different database clusters. Yes, we have several database clusters that need to be starting up. So we correct that list of all the database clusters. We run a check to make sure that it is not already started for some reason. And then we start looping and we call start on the RDS database. And here we wait in a single loop until we either fail or that we have the start database up and running. We wait for 2 minutes before moving on so we don't waste too much state changes. And the final part we do here is, as I said, we're posting the event if we finished starting the database or if we failed the entire startup process. As you can see here as well, there's not a single Lambda function in this picture. We are only using AWS SDK actions from the step function. We are basically writing single line of code when running this operation. And that is one of the super powerful things that I feel comes with step functions. Starting ECS services, there's a bit more of a moving parts on the ECS services. The first part that we take care of is that we list all of our services. We call our cluster and asks how many services do you have in the cluster and what should I be starting up. And the reason for that is we don't want to hard code any number of services and the names of the services because then it would be very hard to extend this by adding a second or newest service into the cluster. Then we one more time use the map state that comes from AWS that loops everything in this list for us and calls the update service where we set the desired count. In the start scenario, the desired count is 1 for development and test environments, and it's 2 for the production environment. And these mechanisms for starting and stopping you use both for scaling down and for stopping and starting completely. The second part of everything, now we want to wait until our services is up and running. The first thing we do is to set a counter to 0. And the reason for that is that if we do not want to loop forever. So if something is breaking, we could end up in an endless loop. And we saw that happening, that for some reason, some ECS services didn't start that they should. They couldn't reach the database, they couldn't load an image, something like that. And then we were stuck in this loop forever. So the first thing is we initialize the counter and set it to 0. Then we check all of these services to see what state they're in, if they have been starting or they're stopping still. And then we increment the wait counter and go into a wait loop. And we wait here until either all of the services have been started or the counter hits a number of retries and we consider everything a failure. And the last part, one more time, what we do is post an event on the event bridge so the next step in the Saga pattern can take on, or we notify back to Slack that everything was a huge failure at this point. And the progress of this entire pattern is posted back to Slack all the time. We can keep the progress in Slack to see exactly what is happening and exactly where we are in this chain and starting and stopping the environment. And we get something like looks like this. We can see that we did a stable update to our stable environment. We started the RDS services. We got a maintenance mode here. The ECS services is starting. Client VPN is starting. So here we can see the flow of everything, and we get those notifications into Slack, and we can follow the progress along if we want to. And we will also see if something would be breaking. Now, starting and stopping, that's one of the fun parts. So let's run one more demo. This demo takes around 15 minutes. I hope everyone has a good joke in hand, because it will be a lot of waiting time. So no, but as a good TV chefs, I have, of course, prepared that, and we will do some editing. So let's move over to Slack. And let's start up our development account. So once again, I write type /mm for our bot. And I tell it environment, which is a top command. I want to start, and I want to start the development environment. And I get a notification back saying that we are now processing the command. And we have acknowledged that we got the command. So let's move over to our AWS console. And we can see that the first part in our Saga pattern is running. And we are now trying to start up our databases. Now this part is what takes around 10 minutes to start up. But let's check our database clusters. And we can see that they are now in starting state, at least. So everything is running as it should. We have 2 different clusters here. We can see that we have no tasks running in ECS because that has not been initialized. And by magic, the databases are now available to us. And we can move to the step function, and it should soon change state or here as well to green. There we go. And we can see that that's been running. The next part should now be running. That is starting the ECS containers. And we can see that we are now in initializing the counter, and we are now waiting for 2 minutes for this services to start up. We can refresh. We have 23 services pending. That's 0 running so far. 1 is up and running. And we'll do it for more refresh. And 3 is pending, so almost done. There's a few services left to start. This is rather quickly. And let's do the final refresh, and we are all up and running. All 23 is running. So move over to the step functions console again. And this one should turn green soon as well, telling us that we are completed. And there we go. Now everything has been starting, and the entire environment is now up and running. We can check the progress in Slack to see that we got a notification saying we did a status update on the RDS. We did once more, went in RDS maintenance mode, and we started up the ECS services. And everything is now up and running, and you can start working. Monitoring then, which is the last part I will show for you today. On the monitoring side, we have what I call direct sources and indirect sources. A direct source is something that can send an event to us directly over the Amazon Event Bridge. That could be AWS Config, Macie, and Amazon CloudWatch. The indirect sources, that's services that send notification to us over Amazon CloudWatch. So that is if we get a message is one of our DLQ in SQS, if the ECS services is failing, or we have problems with the Elastic Load Balancers. Those events or errors are coming to us over the Amazon CloudWatch, so that becomes an indirect source, so to say. And looking in our Slack, this is what we are getting. So in the first top here, we can see that one of our callbacks from one of our banks has failed parsing and has now ended up in one of our DLQs. On the other hand, we can see on the lower part, we can see that someone has created an S3 bucket and has forgot to turn on our SSL requirements, meaning that we get a config rule that is breaking, and we get a notification saying that this bucket is out of compliance. And all of this is like flowing over to us in Slack. I've been talking a lot about Slack, and that is the integration we have built today and that what we are working on. But this thing is, as I said, we had a requirement that everything should be a modular building block. And that also goes for our integrations. So each of our integrations are isolated. And if we would like to add an integration like towards Teams, what we need to do is build that integration part only. And everything on the other side of that integration would remain the same. We don't have to build something custom the entire way. We only need to build these modular integration points. And the magic behind that is keeping the event buses as common. So by keeping the event buses common, everything on the left side of those, the integrations, can be super modular and implemented one by one. Keeping the event buses, everything flowing to the environments account are still working. Now, future. Are we done with this implementation? Yeah, we're super happy with it, but you're never done as a system developer, right? So what we want to improve on is operations and monitoring part. So we want to create a better post-deployment monitoring. So if we deploy something to production, we want to run smoke tests and stuff like that. We want to have that feedback directly into Slack. We would also like to be able to start our automatic test suites from Slack to say, yeah, I want to run the automated test suite for service X. Have all of those running in cloud and get the results back to us. And then, of course, add new operations, add new alarms. And here's only imagination that puts the boundaries on what we can do with our environment. And that is something we are asking our developers constantly. What do you want to do? What are we missing? Is there anything we can improve? The second part is I've been speaking for 37 minutes and I have not talked about generative AI one single time. So I feel obligated to do that. We want to do some generative AI implementation, so like assisted error debugging. So the messages that comes from CloudWatch can sometimes be really, what? I don't get that. So having that translated by an LLM would be awesome. It would also be great to do documentation search. So everyone that has documentation knows that for some reason tend to rot and go fish. So by having a RAG solution on top of that, it would be super easy to just write in Slack hey, what's the vacation policies? And here we go. And of course, agentic workflows. I think if last year was the year of AI, this year is the year of the agentic workflows. So what we want to do is implement an MCP server for all of this. So instead of leaving your IDE, you could tell Copilot that we're using that, hey, can you start the environment for me? And it could just go and do that by having the support from an MCP server or an MCP tool. Which means that our developers don't even have to leave the IDE, they can just keep it there. So that's one of the big things we want to implement for the future. So with that, I say thank you very much for listening today and hope you enjoyed. And if you want to connect with me, you find me on LinkedIn, scan the QR code. So thank you.